What's up guys, in today's video I'm going to teach you and I'm going to show you how to use semaphores in Python, but in this case we are going to do an exercise. This exercise is going to be very cool, so yeah, let's get to that. So let me open the paint to show you how this exercise is going to work. So it is going to be a very simple exercise. First of all, you need to imagine one thing. Let's think that we are at a kids party. And there are 10 kids. I'm not going to draw 10 dots, but yeah, there are 10 kids. And we just have one table in which we have a cake. The thing is that the kids are really hungry, like they want to eat anything. So in the table, there's one cake which is divided in 3 pieces. So let's put it like this. So as soon as they see a cake, the kids go running so they can take a piece of cake. But there are certain conditions. The first one is that they must go one by one. Like they cannot go like 2 at the same time and take 2 pieces. No, they must go one by one. So what you will have is a table with a cake of 3 pieces and a queue of kids waiting for the piece of cake. But it can happen that these 3 kids, for example, take the piece of cake and now we don't have a cake. So in this case, the last kid that took the piece of cake must call the mom so the mom can come and say, hey, here you have a new cake. And she will reestablish, she will bring back another cake. So yeah, that's the problem. It's going to be very simple, and yeah, let's get to that. By the way, you have this code in my GitHub. So if you come here to my GitHub, let's open this. You can see that here in TradingBot, if you come here to tutorials, and you come to, let me go here, Python, here you have the SEMS exercise. This is what we are going to do, and this is basically the same code that I'm going to write. So you have it here in case you want to try it. Let's create the program. First of all, let's declare a macro in which we set the amount of kids that we want. So let's say that we just want 10 kids. So we are going to put here number of kids is going to be 10. This is going to be a global variable. Then another thing that we are going to put is the number of available pieces that each cake has. So we are going to put that available pieces is going to be equal to 3. So these are the 2 main variables that we need for our problem. This variable is going to be changing the value because once a kid takes a piece, we don't have 3 pieces anymore, so we have 2. We have to decrease 1, and the same happens if we have 2. So if a kid takes another piece, we have 1. So now we are going to import threading. I'm not going to explain everything about semaphores in these videos because it is explained before. So what are we going to do now? What we are going to do is to create a semaphore for the critical area. What is the critical area? It is the area in which we modify, for example, variables such as this. Like this variable is going to be modified, but we want this variable to be modified like by 1 thread at a time. So we must check that. And how do we do this? We are going to create a semaphore for that. And we are going to call it mutex. So since we have imported threading, what we are going to do is that from threading, we want the semaphore. And with an initial value 1, like we are going to give it an initial value which is going to be 1. So now we need to define the kid's behavior. And how do we do this? It is very simple. We are going to define a function, let's call it kid, and here this function is going to receive 1 argument, which is just a number, which is going to define which kid is this one. So the first thing that we need to do is that since we are going to use this variable and we are going to modify it, we need to put here global available pieces. we are saying that, hey, this variable is not going to be local in this function. It comes from a global scope. So now that we have this, we can start with the function. Let's say that the kids may repeat, but they may repeat a random amount of times. So for that, what we are going to do is that for e in range, and here we are going to put the random amount of times, we are going to import random, but here we are going to do from random import rand int. So we want that the kids repeat a random number between 1 and, for example, 4. So yeah, now what the kids have to do is to first go to the queue. And how do we express that here in the code? It is as simple as using the semaphore and saying, okay, acquire. So now that we have used this, the next thing that we have to do is that, okay, now we are in the queue. The thread is going to be blocked here. If the thread is not blocked, it means that he can go and take the piece, but before taking the piece, the kid must check if there's available pieces. So we are going to do this. If available pieces is less or equal than 0, then we are going to call mom for cakes. We are going to do this later, but yeah, we are going to call mom for cake so she can bring another cake. But if there is a piece of cake, what we are basically going to do is that we are going to do available pieces minus equal 1. We are decreasing the number of pieces of cakes. And here we are going to put a print. So we can see that, hey, the kid is doing something. So we are going to say, hey, the kid, oh wow, let me use this the kid, let's put here a number, the number n, that's why I said that we are going to use this n. I'm this kid and I'm taking my piece of cake. There are, and let's put here available pieces left. Okay, so now we know that this kid is eating the piece of cake, but piece, I think is like this, yeah. But now we need to do something else to represent that the kid is actually eating. So we are going to use from the time library, from time, we are going to import the sleep function. So we are going to sleep this thread for example, a random number. Let's put here an int between 1 and 6, for example. Yeah. So now that the kid took his piece of cake, the thing that we need to do now is that we need to go out from the queue. So how do we express that? We express that with mutex release. Like this. This is very, very simple. And now what we have to do is that we need to express that the kid is going to eat, because if we leave it like this, the kid is automatically going back here to the queue, and we don't want that. So we want to emulate the kids eating. How are we going to do this? With a print. We are going to put here let me copy all this. The kid and eating. We are going to put and eating. And again, we are going to sleep a random amount of time. And I basically think this is it for the kid. I think that we don't need anything else. And you can see that the problem is very, very, very simple. So, well, let's define this function, which is also very simple. So, as I said before, if we don't have any piece of cake left, we must call our mom and and she will bring more pieces of cake. And how do we express that? It is as simple as saying available pieces equal to 3, and we are going to say also that, okay, let's sleep the process 5 seconds, indeed, not much, and let's say, okay, the mom and let's remove this comma, and I'm bringing more pieces of cake. So that's it. And I truly think that we have almost finished. We need to set here also the global, because otherwise Python is going to think that this is a local variable of this function, but no, we need to take it from here. So okay, we have this here, and I think that that's basically it. So in order to test this, first of all, we need to declare the threads. So we are going to create a list of threads in which we are going to save them, so later we can close them correctly. And in order to initialize them, we are going to put, okay, for I in range, let's put number of kids, we are going to threading, well, no, let's append here a thread, calling here threading thread, and the target is going to be the kid. Let's put here target equal to kid, and the arguments are going to be just the number, which is this one, but here indeed we are going to put I plus 1. And that's it. Now we are going to start that thread saying that, okay, take the last element from this list and start it. So we are going to call start. And finally, once you started, let's put here an S, once you have started all the threads, what we are going to do here is that we need to wait for them. So we are going to use the join function. So for I in threads, not I, let's put T of thread. In threads, we are going to join this thread. And I think that's basically it. So let's try. We are going to open a terminal. And here inside this terminal, what we are going to do is that we are going to use Python and put sem.py. So if everything works correctly, like this, you are going to see that, okay, I'm the kid 1 and I'm taking my piece of cake. I'm the kid 2 and I'm taking my piece of cake. There is one left. Okay, I'm the kid 3, and yeah, this seems to be working really, really fine. But there is an issue, and you may say, hey, but this is not representative, because here we have an order 1, 2, 3, 4, 5, 6, 7, 8, 9. And I agree with you. Why is this happening? Because this is starting the threads in the same order as we create them. So the processes, the kids, come in this order. But how do we fix this? In order to fix that, what we can do in this function is, again, sleep the process a random amount of time. So here, let me put rand int, and let's say 1 and 10, 1 between 10. So with this, we are going to have a random starting point. So let's open another terminal, because this is going to take a lot of time. And here, let's put python sem.py. And oh, I forgot to to save, so I have to open another terminal. So let's save here, and again python sem.py, and let's check now. Okay, so now we are waiting, and you can see that now the first one is the second kid. Now we have the 10 kid. But it doesn't matter, like everything is working fine, because here we have that there's 2 left, 1 left, 0 left, and the mom should come now. Okay, you can see that I'm the mom and I'm bringing more pieces of cake, and as soon as the mom comes with more pieces of cake, the kids start taking more pieces. So you can see that the problem is working fine, and this is a very, very simple problem, but you can understand in a better way the critical zone, the critical area, I think is called in English. And the critical area are the areas in which you modify important variables such as available pieces. Why is available pieces important? Because it's shared between all the threads. So this is the critical area. Here, there's one thread at a time. But you may be wondering, hey, but what happens if I don't use this mutex? You're going to see that things are going to get a little bit crazy. So let's open another terminal, let's save, and let's execute it now. So if I put this, it will take a little bit of time because we have here the sleeps, but it seems that everything is working fine until now. But yeah, well, now you can see here that we have a -1 that shouldn't be there because sometimes it's trying to take the value at the same time and the computer gets confused. Since there's a lot of time here, we cannot see that well, but let me reduce the time. Let's remove the sleeps and you are going to see that this is going to really get crazy. So let's put something like this. And let's open another terminal because this is going to take a lot of time because it's a long program. So here we are going to put this. And yeah. So now we are waiting for the mom. And here you can see that we have -1, -2. Yeah. This is the problem if you don't use semaphores, that things get a little bit crazy. So that's why semaphores are very useful. So here I guess that, well, keyboard interrupt, this is because I pressed Ctrl+C, so that's fine, I guess, yeah. So yeah, I hope you enjoyed this video. I hope you understood you understood this problem. It's a very simple problem that came to my mind. So yeah, I hope you understood it, you enjoyed the video, and if so, give it a like, share, subscribe, and see you in the next one.